Hello everyone. I wanted to remind you about what we were talking about in Math Honors just before we went on spring break. If you recall, that day we were going to celebrate Pi Day, and I showed you a way that Archimedes used to estimate the value of pi by inscribing and circumscribing regular polygons about a circle. So I'm going to reproduce the example that I did in class with you using a hexagon. If you recall, your homework was to do the same thing that I'm doing here for an octagon. So I'll go ahead and run through how to do this again. So here's my circle, and what I did was I used a ruler and came across and drew a diameter, and then since I'm inscribing, and remember, inscribing means I'm putting the polygon on the inside of the circle. Since I'm inscribing it on an arc that's 180 degrees, I need to have I need to create three equal arcs, which of course would be 60 degrees apiece, and they would be equal to the central angle here. So in doing that, I've created my polygon here, and I just need the top part. So in this estimation, I want you guys to be thinking about the perimeter of the hexagon with respect to the circumference of the circle. Now, I think you would all agree that the circumference of the circle is bigger than the perimeter of the hexagon. So we're going to start with that idea. The circumference of the circle is greater than the perimeter of our hexagon. So what is the circumference of this circle? Now, when we're generating a rule, we're not going to apply values, we're going to use a variable. So let's call the distance from here to here r. Stands for radius, of course. Now, as I'm looking at this triangle that I chose to put inside of my hexagon, I have to remember a few things about it. In a hexagon, each of these angles here are 120 degrees. Well, I just bisected that, which makes this 60. But this one's also 60 degrees. So that's something that we're going to just think about later on. But how I'm going to use it right now is if this is 60 and this is 60, this has to be 60 as well, which means this is an equilateral triangle. And where I'm going with that is that means that all the sides are r. So is this one. Now, the circumference of the circle is equal to 2 pi r. Okay, well, here's my r. I'm looking at my circle. And the perimeter of my hexagon is going to be, since it has 6 sides and one of them is r, the perimeter will be 6r. If I take this inequality and solve it for pi, I would divide both sides by 2r, and pi has to be greater than 3. We actually already know that, just because it's been a few years since Archimedes did this, so we've estimated pi to many, many, many places beyond the decimal, and I'd like to congratulate those of you that memorized quite a few. And right now what we have is that pi is definitely greater than 3. Well, let's put a cap on it. Pi is greater than 3, but it's less than what? Well, here I put my polygon inside, so I inscribed it. So now what I'm going to do is I'm going to take and I'm going to circumscribe my hexagon around my circle. And I did this ahead of time because it takes a few minutes, but what you'll notice is I'm going to go back now and just go ahead and erase some of my extra lines, because when I did this, I just used a ruler and a compass, so I had my straight edge. So I drew my circle, put in a diameter, and then I was able to, I did use a protractor. I measured the 60 degrees, and then I could just copy that around to these two spots here. And then right here, I have this point and I have the center of my circle, so I can just go ahead and draw straight across. And then I've created 60-degree angles in here. which means that if I take my figure here, I'm going to go ahead and just really quick make these lines a little bit darker for you to see. And you're going to see that I'm circumscribing this hexagon about the outside. That's what circumscribe means. About the outside of my circle. And each one of these places that the hexagon touches the circle, it touches it just in one spot, and that's called a tangent. Just a few fun facts. Some of you know these things, some of you may not have been introduced to them just yet. So now I think we would all agree that the circumference of our circle here is going to be less. The circumference of our circle is going to be less than the perimeter of our hexagon. Well, the circumference of our circle hasn't changed. That's still 2 pi r. But the perimeter of our hexagon has changed. Now, this measurement right here is still r. Now, the thing about r is that while this measurement here is r, I need to know what this side is. And the game's changed a little bit here. So this measure here is still 60, but what I'm going to do is draw this segment right here, like that, and bisect that angle. So now this angle is 30 degrees. Since this is tangent to the radius, it's perpendicular, which makes this 60 degrees. So now I have a special right triangle, a 30, 60, 90. If I know the long leg of a right triangle, I can say that I take the long leg and divide it by root 3 to get the short leg. So the short leg of this triangle is r over root 3. Now this length right here is half of this side. So one side of this hexagon is 2 of these. And what I'm going to do down here is I'm going to rationalize that value, r over root 3. And I would do that, oops, you can't see, I would do that by multiplying it by root 3 over itself. So that gives me r root 3 over 3. So that is what this is equal to. Well, if half of the whole side is equal to that, then I need 2 of those. So one side of this hexagon measures 2r root 3 over 3. Now I have 6 of those all the way around. So if I take that value and I multiply it by 6, that's going to give me the perimeter of my hexagon. So that's going to give me 12r root 3 over 3, and we're going to clean that up because 3 goes into 12 4 times. So the perimeter of my hexagon is 4r root 3. Now, just like I did before, I'm going to divide both sides by 2r. And then you're going to see that pi will be less than, the r's of course factor out, and I have a 2 here, 2 root 3. And the value of that to 3 decimal places is 3.464. So now what I've done is I have come up with, and I'm going to try to let you guys see this here, pi being greater than 3 but less than 3.464 means that the range for pi is greater than 3 but less than 3.464. So you have been tasked with doing this very same procedure using an octagon instead of a hexagon. I know that a couple of you have already done that, and what I'm asking you to submit as your assignment is something similar to what I've just shown you here. I'd like you to submit a picture of your circle with an inscribed octagon and your work. And I would like you to submit a picture of your circumscribed octagon and your work. And then your range. I hope this helps as a reminder of what you guys were doing and what I had asked. If you have any questions, please feel free to email me, and I hope you have a great day. Bye.